Hi everyone, Mr. Markwick here. In Year 12 General Maths, the statistics topic is pretty much broken into two main subtopics, looking at the normal distribution curve, which my class, we've already covered that, and the second part is looking at bivariate statistics. So looking at two variables and if there is a relationship or an association between those two variables. And today we're going to be focusing on categorical variables or categorical data in particular, and then we'll move on to looking at numerical variables or numerical data for the remainder of this topic. So this student here, Sophie, suspects there is a relationship between a student's gender and their grade in English. She surveyed the English students in her year level and found that of the 50 boys, 15 of them scored an A, 21 scored a B, and 14 scored a C. And of the 20 girls, 10 scored an A, 8 scored a B, and 2 scored a C. She's put that into a two-way table here that shows what grade the boys got, and that there were 50 boys in total. What grades the girls got, there were 20 girls in total, and obviously the total number of students that got A's, B's, C's, and the total number of students overall. This doesn't really help us make that association or find that relationship between the gender and whether they are better at English or not, because here you can see that there's actually more boys were surveyed, or more boys were enrolled in English, or more boys were studying English at this school. So to make a bit more of a fairer comparison, we're converting those raw numbers or that raw data into percentages. And that's done here in this two-way table. So you can see that 30% of the boys got an A, 42% of them got a B, and 28% of them got a C. For the girls, 50% of them got an A, 40% got a B, and 10% got a C. So this then helps us see that, yes, in fact, there is actually a relationship between the gender of the students and how well they did in English. In particular, it shows that girls predominantly scored or achieved better in their English results, okay, with 50% of them getting an A compared to only 30% of boys getting an A. So let's look at an example here. That's pretty much what we're going to be looking at for this video, that sort of stuff. So here is an example where 200 adults were asked whether they were left or right-handed and whether they were full-time employed, part-time employed, or unemployed. Again, those results are shown here in a two-way table, but you can see that from those 200 people, only 20 of them were left-handed, and the majority, 180 of them, were right-handed. So it's a little bit hard to see from just the raw data whether there actually is a relationship or an association between being left or right-handed. Will determine, whether you are more likely to be full-time, part-time, employed, or unemployed. So we'll get to that in a minute, converting those into percentages to make that comparison. But the first question there says how many of those adults surveyed were right-handed. So I'm going to move across the column, the row here, and it says that 180 of the 200 were right-handed. So that's the answer there. How many worked part-time? Okay, so now I'm going to look at the part-time column. 73 in total were part-time. And how many were left-handed and worked full-time? Okay, so here I'm looking left-handed and full-time, where that row and that column meet. It says that 11 left-handers that were surveyed at least, were in a full-time employment. Now what we're going to do is we're going to convert those numbers, that raw data, into a percentage. And I've set up a two-way table just below for that data. Now it's important here to read the question. It says, write the element in the table as a percentage of the row total, right? So I'm looking at the row total here of 20 left-handers and 180 right-handers. So to work out the percentage of left-handers that were in full-time employment, I would take the frequency of 11, divide that by the row total, which is 20, and multiply that by 100. Percent means per 100, obviously, to give me a percentage of 55%. Then I would look at the 7 left-handers that are part-time. Again, it's 7, the frequency of left-handers that are part-time, divided by the total number of left-handers, that in this case is the row total, again multiplied by 100 to convert that to a percentage, which would give me 35%. And unemployed is 2 divided by 20 times by 100, which would give me 10%. Now I'm just going to fill in the rest here because I've already done this working out. So right-handers full-time employed works out to approximately 53.9%. Right-handers that are part-time employed works out to approximately 36.7%. And right-handers that are unemployed works out to 9.4%. And then obviously the total, again, for the total here, I'm looking at 100, and for this cell here, I'm looking at 108 divided by 200 times by 100, which works out to 54%. The total number of part-timers would work out to 36.5%, and unemployed would be 9.5% in total. All right, so the next question then says, what percentage of left-handed people surveyed work part-time? So left-handers that work part-time, 35% of those that were surveyed and are left-handed work part-time. But now that I have this, this percentage table, it's a bit more of a fairer comparison to make to answer this last question. Does an adult's left or right-handedness appear to affect their employment status? So by looking at this, the answer to that is no. And why is the answer no? Because you can see that the row percentages are pretty much even, depending on, regardless of, whether they are left-handed or right-handed. So full-time left-handers, 55%, full-time right-handers, about 54%, part-time left-handed, 35%, right-handers, 36.7%. So they're pretty similar. So the answer to that question is no, because the percentages are similar. I'll just keep it short and sharp there, across those categories, okay? Which was different to when we were looking at the first example, where those percentages were actually quite different, in particular looking at the A grade and the C grade for the boys and the girls, all right? So that suggests that there was a relationship between your gender and how well you do in English, but in this case, there is no real relationship between, whether you're left or right-handed and your employment status, okay? Because those values are very similar, okay? So that's pretty much it for this video, looking at, an association or a relationship between two categorical variables.